Hopefully you just finished watching the video, Rational Functions and Graphs. That introduced the concept of a rational function, which is a function with an x in the denominator. So today, this lesson is going to be about vertical asymptotes specifically. We, in our last lesson, saw that y equals 1 over x looks like this. This piece, the axis, is not part of the graph. But we saw last time that this line right here, where the behavior of the graph is getting closer and closer on either side here, is called a vertical asymptote. And in this case, the vertical asymptote is the line x equals 0. Now look back at the function. If we had found the domain of that function, we can see that we can use any value of x that we want, except right here when x equals 0. So our domain is going to be everything coming over on this side, all the way up, but not including 0. So we put a parenthesis there. So we have the interval negative infinity to 0, not including 0. And then on the other side, we move on. We're starting at 0, but not including 0, just infinitely small distance here to the right of the axis, and then it just continues on forever. So we have the interval 0 to infinity. And we have either this interval, x is in this interval, or this interval to be in the domain. So we can use the symbol union for or. Notice that my excluded value right here, the one that I can get infinitely close to but not include, is 0. And that is where the vertical asymptote occurs, at x equals 0. Now look back at the function. Think about why algebraically x cannot be 0. And hopefully you were thinking, because you can't divide by 0. So what we're seeing algebraically that x cannot be 0, we see on the map, or the graph, that x cannot be 0 on our domain. And then that is where our vertical asymptote occurs. And that will always happen. So let's say that we have a function y equals 1 over x minus 4. If you think about how this graph would look using transformations, write down on your paper what the transformation for this graph would be. Hopefully you said, not left, right 4, because we have a minus 4 inside of the function. So we'd have the same graph that we had up there, except it would have moved over 4 units. So my vertical asymptote here, that was at x equals 0 on this graph, will move over to x equals 4 on this graph. And that makes x equals 4 our vertical asymptote. And then the rest of the graph will go ahead and move over as well. It'll just follow right along. The whole graph will just move over 4 units. These should be much closer in there, but I'm having a hard time drawing that. Okay, so the vertical asymptote moved over to x equals 4. And notice right here in the denominator, if I set that denominator equal to 0, I get x equals 4. Because the value of x that makes the denominator equal 0 is where our vertical asymptote occurs. Go ahead and write what the domain on this one would be. We're coming all the way over from negative infinity, all the way up to 4, but not including 4, and then we're jumping across and going across from 4 onto infinity. So the excluded value is what we're jumping over here. It is the equation of the vertical asymptote, and it is the value of x that makes the denominator equal 0. So that gives us kind of a rule for how we find vertical asymptotes. Vertical asymptotes occur at, now remember, denominator means the bottom of the ratio, the bottom of the fraction. So vertical asymptotes occur at the values of x that make the denominator equal 0. But we have a word for that. We have a word for a value of x that makes something equal 0. And that is actually the 0 of that polynomial. So the vertical asymptotes will occur at the zeros of the denominator. Of the rational function. That will also give us our excluded values from the domain. And remember that a vertical asymptote will always be a vertical line, x equals something. So you can't just say the vertical asymptote is 0, the vertical asymptote is 4. You have to say x equals 0 or x equals 4. Okay, so that's our rule for finding vertical asymptotes. Let's go ahead and look at one that has some other interesting behavior here. So let's look at y equals 2x plus 1 over x squared minus x minus 6. And if I ask you to find the domain and then find the vertical asymptote, and we're going to see on this one that we actually have more than one vertical asymptote. So think about what you would do to find the zeros of the denominator. You can pause the video and work on that for a minute. Okay, hopefully what you did was that you set x squared minus x minus 6 equal to 0, because that's how we find zeros, is we take the polynomial and we set it equal to 0. Now this is a quadratic, so we're going to use quadratic methods to solve this equation. We do have a b term, so we get it in standard form, keeping x squared positive, which is this case already. Then our next step would be to try to factor that. And since we have x squared, we can just do x times x. And there's no number in front of the x squared, so we can do minus two numbers that multiply to give negative 6, add to give negative 1, which are negative 3 and positive 2. And then we set each of those equal to 0 and solve for x. And notice, as we learned in our lesson on higher order polynomials, we have two factors, and each factor has a 0 associated with it. So now we see that we have two zeros, x equals 3 and also x equals negative 2. So both of those are excluded values. Both of those are values of x that if I plugged in to my function, I would get 0 in the denominator, which I cannot have. So I think it's going to be easier to see if we actually draw our vertical asymptotes first. Now, it's important to recognize here that the x equals 3 here, the 3 and the -2 are just numbers. But the vertical asymptotes are vertical lines that occur at x equals 3, which gives us our vertical asymptote here at x equals 3. And you have to put the entire thing, x equals 3, because it's an equation of a line. You go ahead and put the other vertical asymptote and write what it is. And we see that the other vertical asymptote is x equals -2. And again, you have to write the entire thing, x equals 3, x equals -2, because it is an equation of a line. Okay, so now we have graphed the two vertical asymptotes here. Let's go back and look at our domain. Notice that we have 3 separate intervals. We have this interval, we have this interval, and we have this interval. So we have 3 separate intervals. Go ahead and write what those intervals are using interval notation. And we see that we have -infinity to -2, not including -2. And then my middle one is -2 to 3, not including 3. And then 3 to infinity. So we have actually 3 different intervals on this one. And it turns out that those intervals are the same thing as your domain. I'm not going to have enough room here. Let me kind of block this off. So the excluded values from the denominator are 3 and -2. So our vertical asymptotes are at x equals 3, x equals -2, and our domain is the 3 intervals jumping over -2 and 3. Go ahead and leave this graph. I'm going to actually leave it just the way it is. We're not going to draw the picture yet. So in your notes, go ahead and stop here where you are, and then leave about 8 blanks underneath it. We're going to come back and look at the concept of horizontal asymptotes, what the rules are for that. And we're also going to talk about how we find some other points and get an understanding of what the graph looks like. So at this point, just leave this, and you're going to come back to it in a little bit after you watch the next video, horizontal asymptotes.